Okay, so we're looking at the pendulum here and the potential energy. It's at its lowest point up to its highest point, and it kind of swings through that range there. And at its lowest point, we have our maximum kinetic energy, as we learned before, but our least amount of potential energy. And then up here, we have our potential energy as a maximum. So what we're interested in here is what is the potential energy difference between these two positions. So if we were to say this is the energy, potential energy final, and this is the potential energy initial, we're looking at the difference there. What is the change in potential energy? Now, we can look at this a couple ways. One is we can say potential energy of position, is the average force times the distance. And so we can look at it from the point of view of we're getting from this low point to this higher point, and we're overcoming gravity in order to do it. So we could look at it as we have our force of gravity and we have our distance there, which is just the change in vertical height. And those are both parallel. So that is definitely one way to solve this problem, is to say, well, the average force is 0.5 newtons, because that's the weight of this pendulum. And so the Fg, and then we have the d, which we're told it moves 12 centimeters above its lowest position. So that means a vertical movement of 12 centimeters. So we can convert that into meters, and we're set to calculate that out. So 0.06 joules. Now, that's the change in potential energy. The initial potential energy, or the potential energy at the very bottom there, is what we would consider zero. Again, we have to stop and say relative to what? Well, the reference is the lowest point, and then the measurement of the potential energy change is from there up to its highest point. And that's where our 0.06 joules is coming from. That's the change in potential energy.